Hi, this is Tim. Today we're going to talk about the I, or integral, of the PID equation. For this video, we're going to be using Industrial Concepts PID trainer along with our Compact Logics trainer. And I'll put links to both of these down in the description. Also, before we get started, please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. And any questions that come up, feel free to put them in the comments. Your question this week could easily be next week's automation topic. Now, before we get too far in this, I need to make a correction in how I had you set up this PID initially in Studio 5000. If we open up our PIDE, then I had you set this up for a dependent equation. We need to switch that to an independent equation. And I said in the earlier video, that's the way I preferred. And really that comes down to is that's the first one I saw was done like that. And like so many things, we take what we learned and we copy it. But when I actually got breaking it down, at least for breaking this into these chunk size bytes, it was easier to start with the independent equation. So first, let's make sure we understand these two equations. And don't let these overwhelm you. We're going to break them down really small, really quick, and you're going to realize, oh, you already know a third of it. But if we just highlight the PIDE and then hit F1, this will bring up our PIDE equation. If we scroll down a ways, past all the variables, then we are going to see, mainly, yes, here we go. There's our independent gains formula, and here is our dependent gains formula. Now, I'll probably do a supplemental video that explains more of the differences, but long story short, the dependent gains formula multiplies the proportional gain by the integral and the derivative, as well as the proportional part of it. And that makes it a little difficult to separate them and understand them individually. If we scroll up to the independent gains, I wrote it down here, we can actually break this equation out. And so the proportional is this section, the integral is this section, and then the derivative is this section. Now, for the proportional section of the PID, which we did in the previous video, it doesn't matter. When you actually work out the math for the exercise we did, it does the exact same thing. So this week, we're going to isolate and only use the integral. And to do that, we're going to do the same thing we did in the previous video. If we open up our PIDE, then our proportional, we had a value in, but we set the integral and derivative to 0. Now, I'm not going to get into the weeds with this equation yet, but the most important thing you need to understand is that any number multiplied by 0 will be 0. And that's what we had done in the previous one, is we had Ki, which is the integral, at 0. Well, 0 times anything is going to be 0. And then we had Kd, which is the derivative, at 0, which anything times 0 is going to be 0. So in that case, we have whatever we came up for a proportional plus 0 plus 0. So it was just proportional. And we're going to do the same thing this time. We're going to set the Kp to 0, which is going to make this whole proportional section 0. And we're going to keep our Kd at 0, which is going to knock this out. And that's going to leave us with this equation, which is still a chunk, but I think we can break it down and understand it. So if you haven't already, if yours is set on dependent equation type here, change it to independent. Then let's set our proportional to 0. And for now, let's just throw any number into our integral. Let's throw a 1 in. And then our derivative should also still be at 0. Now, if you recall, the proportional required a change in the error to actually get a change in our control variable. The integral is based off of time. So we're going to slow down time a little bit. Our timing, well, one, let's make sure we remember our timing of this PID. See, we have timing mode, and then we have it at periodic right here. And what that means is we go to our periodic task, properties, configuration, and right now our sample rate is 10 milliseconds. Well, we're going to slow down time. We're not slowing down time, we're just slowing down the update rate. And so let's make that 1,000 milliseconds or 1 second. And then let's separate the actual level from our PID. That way we can see exactly when it's doing what. So let's go into some edits, and we have a level in inches. So let's change this to fixed level, and we'll need to create that, and it's going to be a real tag. And we'll go ahead and finalize those. And mainly, okay, our fixed level right now is 0, and our set point is 6 inches. So we're showing 100% here. So just so we understand first how this even works at all, let's change this fixed level here to 8. Now you see it's starting to go down. And so what it's trying to do is it's trying to lower that output to lower this fixed level down. Now we need to know exactly how much is it going down. So first, let's trend this exactly the same as we did in our proportional video. So let's go down to Assets, and let's find Trends, and right-click, New Trend. I'm just going to call this our PID Trend. Next, and we are going to go to our PID program for scope, and PIDE. Now remember, chances are yours is 1, but I did that one video where I ended up making mine number 2 where I was showing you something. But find your active PID, which is what you have it named right here. And then we want to go and find the CVEU. We're going to add that. Remember to hit this add button. It kind of feels like you ought to hit the finish button, but you got to hit the add button there to get it down here. Now we'll hit the finish button. And we'll hit the run button and see what this does. Okay, and we have a very familiar stair-stepping pattern. Now it's way too fast for us to understand anything. So let's right-click and go to Chart Properties. And let's click our X-axis. And let's change our time span. Let's just start with 60. Okay, so now we can see that it is doing a very obvious stair step through here. All right, and now we can't see our numbers here because they're all whole numbers. So let's right-click the chart property again, and let's go to our Y-axis. And down here we have decimal places. So let's throw 2 decimal places in there. We'll apply that. Okay, so now we can see the exact number. And we're going down, and yeah, it's not still super clear. Now, one thing it is clear is this is a very repeatable stair step through here though. But we're not sure how much it's going down. So we're going to add some ladder code to figure out how much is this integral changing each time. And we could do this right in this function block right here, but let's go ahead and do it in ladder, mainly so that we can see that we can have a mixture of these and you can actually jump in between them. So our PID routine here is our main routine of this PID program. But we can right-click it, add, new routine, and we can select a ladder diagram. And I'm going to call this Integral Difference. Now we have to call that the same as any other routine. And you can do this anywhere, which I struggle a little bit with. But if we just right-click anywhere, we can add an element. And just start typing JSR, and that will get you to the jump subroutine. And now what routine do we want to jump to? It's going to be that integral difference. We can put that in. Okay, and yeah, now this little root JSR right here that's not actually connected to anything is calling this integral difference program. So now what we're going to do is we're going to look at the current integral compared to the previous integral. So we're going to go to our Compare tab, and we're going to bring down and not equal to instruction, and we're going to look at the PIDE 02.CVEU. And source B is going to be previous CVEU. And that we'll need to create. So right click, new, and we're going to make this a real tag. Create. And so if it's not equal to, we want to subtract the current value from the previous value and store it. And that's going to tell us what the change was. So we're going to go to the compute math, and we could either use the compute, or in this case, I'm just going to use the subtract instruction, and I'm going to drag source A over to source A, source B to source B, and we're going to call this the difference in CVEU. We'll need to create that. And again, I want to make that a real. It's going to default to a dim, but we want it to be a real. And now what we're going to do is we're going to add a branch here. And we're going to use a move instruction, which right here on the move logical tab, we have move. And we're going to move our current CVEU to our previous CVEU. So what this is going to do is any time that our integral changes, then first it's going to subtract and find the difference between the current and the previous CVEU, and then it's going to write whatever the current is to the previous. That way it's set up for the next time it changes. So let's put that in there and see what it does. Okay, now if you have taken the time that I have taken to do mine, then yours is not going to change. And let's go to the PID routine so we can see why. If we go up to our PIDE instruction, then our CVEU is now 0. But our fixed level is 8 up here, and our set point is 6. So it's still trying to drive this ball down. In this case, we're just going to move it. We're going to move this fixed level, make it 2. Okay, and see, we've started adding to our output again. So let's go to that integral difference. And yeah, the numbers are moving around, but the main thing we want to focus on is you notice this integral is always the same. And that's because it is based off of the error each time that integral fires. So going back to our equation here, first this is our new values. Control variable n. Control variable n minus 1, that was our previous value. So we're going to take whatever we figure out here and we're going to add it to it. So there is our integral value, ki, and it's going to be multiplied by our error. So what does 555 mean in all this? Well, that can look a little confusing because I just told you to arbitrarily throw some numbers in. So now let's throw some numbers in that we probably can work out and figure out exactly what this value is that we're getting. So let's go back to our PID routine and mainly look at the difference between these two. So right now our fixed level is 2 and our level set point is 6. If you subtract those two, you're going to get 4. Let's make it 1, because 1's a very easy number to at least start working with. So what I'm going to do is I'm going to change my fixed level to 5. Now let's go back to our integral difference. Oh, and okay, in the time we did that, we're back to that hard limit. So but before we were at 0, well now we're at 100. So let's go back to the PID routine and let's change our fixed level now to 7 so that it's 1 greater than the level set point, because it's going to do the same thing, only it'll be negative instead of positive. Now let's get to that integral difference. And okay, we have a value of like 1.3 something crazy. And what we need to do now is we need to get our units just a little bit scaled more so we can start kind of wrapping our head around this. So let's go back to our PID routine and open it up. And mainly you see these units here are in minutes. Now I don't want to go to 60 because the first thing you're going to say, well, 60 seconds in a minute. Let's actually make this 6 because I don't want to speed it up too much. So let's hit apply on that. And now let's go to our integral difference. And okay, it looks really close, but it's still not right. we're at 0.833 is what that increment is every time. And the reason is, if we go back to our PID and open it up, then we go to our EU limits tab, our max span is 0 to 12, not 0 to 10. And so we put a value in here of 1. Just change this value. Actually, let's go for the easy. Level set point, let's make it 6.2. And now let's go look at this integral difference. Now we have an integral difference of 1. And I think that'll be an easy value for us to really start understanding what is going on here. Let's go back to our base equation right here that we were using to understand the integral. And first, let's understand some values of it. So here are all the values. And yeah, I know there's a lot of words here, guys, but I'm trying to break down this integral as basic as I can. And so first we have CVN, and that's our control variable percent. So that is going to be this first piece right here. Then we have CVN minus 1. And that is the exact same thing as the above, except for it's the previous control variable. So that is the second piece right here. So then we have KI, which is the integral that we've entered in our PIDE instruction. But do note that it's in minutes. That's going to be important in a second, or it's 1 over minutes. And then we have an error in percent of span, which we're going to talk about in a second. And then we have our update time, which we know is 1 second. Now, I said there was a catch to that integral because it's 1 over minutes. Well, we're talking about seconds right now. So we need to get it in seconds. So our integral right now is 6, 1 over minutes. So if we go to our calculator, to get it into seconds, we need to divide by 60. Because you remember, it's 1 over minutes. So 6 divided by 60 is going to be 0.1. So now we know our integral, and we also know our update rate. And that's going to get us to this equation right here. So now our control variable will be our previous control variable plus 0.1 times error times 1. So now all we got to do is understand this error, which most of, again, is about getting the units right, because it is actually mostly in percent of the scaling, which we did 0 to 12 on. So if we look at our error in units, it's going to be our set point value minus our process value. Well, we fixed both of those, so they couldn't change. So if we go back there, our set point variable is 6.2. Our fixed level is 5. 6.2 minus 5 equals 1.2. But that's 1.2 units. That is not percent of scale. So once you take into account percent of scale, that's going to be your error in units divided by full scale, or 1.2 divided by 12, which is going to equal 10. So if we plug that into our equation, we're going to get that our control variable will equal our previous control variable plus 0.1 times 10 times 1. Now let's run that through a calculator just to make sure that we see what we end up with. So we have 0.1 times 10 times 1, and that equals 1. So that means that our control variable will equal our previous control variable plus 1. So remember, we had this switch here that we could actually switch off our PID control. So if we switch it off, it's going to take that CVEU back to 1. Now we can switch it back on. And if we go over to that integral difference, we're going to see each time it is going up by 1. So now let's make our error half. Let's stick in even numbers. And I kind of halfway I regret. I wish I'd made the scale in 0 to 10 now, but we're pretty far into this with a 0 to 12 scaling. Let's go to our PID routine. And let's change this level set point from 6.2, let's make it 5.6, which would make it half of the error that it is right now. 5.6. And now let's go look at that integral difference. So now instead of us changing by a percent of 1 each time, we're changing by 0.5% each time. Every time that we have an update, which right now our update rate is 1 second, it's going to take that error and multiply it by that integral. So whereas the proportional, you actually had to have movement or a change in the error state to get it to react. This integral happens every single update rate. So play with this sum. Let's go ahead, let's throw another value in there just so we can see what would happen. Because, okay, just think about this, even pause the video if you need to. All right, we were using 1.2 as the difference, and then we went to 0.6. What will be our percentage change in our control variable if we made this 2.4? So let's see, a fixed level of 5 plus 2.4 would be 7.4. So we make this level set point 7.4. Can you figure out what your control variable is changing by now each time? If we go over here, it's going to be 2%. So I know I threw a ton of numbers at you. So I want you to spend some time right here and really understand this integral before you move on. Do not add the proportional back into it. Do not add the derivative to it. Just get this integral equation down and make sure you really understand how it works. Because next we're going to, we're either going to move on to derivative, or we may go ahead and do what does the proportional and the integral do together. I'm not sure which way we're going to go there, because really I kind of naturally want to go to what is PI control now, but also we're kind of breaking it proportional, integral. Maybe I should go ahead and break out the derivative next. Not sure which way we'll go on that. So I hope this video has been helpful. It had way more math in it than I really like, but I do need your feedback on this pretty quick because the derivative one will actually have a little more math, and I'm going to try to break it down as basic as possible, but also I don't want to sugarcoat it either. One analogy I always hear is that the proportional is your past, the integral is your present, and the derivative is your future, but I don't know that I fully embrace that. I believe we really need to fully understand what these do and how they end up with these magic numbers. So let me know what you think. This actually is the third time that I've made this video. I was very unhappy with the first two. One was too simple, the other was insanely too complicated. So hopefully I hit in the middle on this one. So again, please hit that like button and subscribe to our channel. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!